Ladies and gentlemen, we're going to learn how to do electrical resistivity measurements. This is a copper sample, a rectangular sample, and what I'm going to do is I'm going to measure 3 widths. So one width is 0.976 inch. Let me change it to millimeters because our work will be in SI units. So the width is 25.63 millimeters. Another one is 25.42. And the last one is 25.61. And then I'm going to take the average. Then I'm going to take 3 thickness measurements. One of them is 6.33. The second one is 6.33. And the last one is also, well, it's 6.45. So I will take a average of the thickness, average of the width, which I took before, and that is going to give me the average area, where area is the thickness times the width. Now I'm going to take the sample and I'm going to put it in this sample holder. This is a 4-probe sample holder. These are the stands. This is the base. These 2 knobs go to an ammeter. These 2 knobs go towards a voltmeter. I'm going to read in millivolts. I'm going to push the 4 rods towards the sample, and I'm going to read a current of half an ampere, and I'm going to look at the voltage. The voltage is 0.0018. This is a very sensitive instrument. Even while we talk, it will keep on fluctuating. .0230 millivolts. Then I'm going to go to a 1 ampere. You're going to find that the voltage will increase from 0.00 to from 0.002 to 0.003. Good enough, 0.00356 millivolts. Then I'll go to 1.25 amperes. And now I'm going to read 0.004. Now notice we're reading too much significant digits in the voltage. And all what we need is really the first 4 digits. So don't worry if you see the fluctuations, but here we have 0.00427. So I'm going to return back the current to 0. And I'm going to release the sample. What we do is we measure the current Actually, we decided the current, but we measure it as half an ampere, 1 ampere, and 1.25 amperes. This is the independent variable, which is the voltage. We read it 3 times as 0.002 milliamperes in half an ampere, as 0.003 amperes in 0.003 volts, 0.003 millivolts for the 1 ampere, and 0.004 millivolts in the 1.25 amperes. So as the current increases, the voltage increases. Why do we do that? We want to find the average current, we want to find the average voltage, and from there we're going to get the average resistance. You're going to see that V is IR, which is Ohm's law, and the R is V over I, which will give you the R in ohms. Later we're going to see in the lecture that the resistivity is equal to R times A over L. The L is this fixed distance of 1 inch or 2.54 centimeter, and the area is going to be the average width, which we calculated, and multiplied by the average thickness, which we actually measured, not calculated. We're going to take the 3 widths, take the average, the 3 thicknesses, take the average, and then that will give us the area. So this is what we need to know about the experiment, and we're going to see the calculation and the theory in the lecture. Thank you.